Okay, so you're all very welcome to our online coding session, and we're going to do a wee bit of Python for real beginners. Okay, so we are going to use a tool called Repl.it. I think it's pronounced Repl.it. I could be totally wrong, but it's the website Repl.it. So when you go there, you're going to get a login, and what we're going to do is we're going to go through that login for a new user. Now you can see I've got my screen split into two, and that's just how maybe you should think about doing this. Is I'll have the video on one side and I'll have the website Repl on the other. And Repl is going to allow us to do some coding in the browser without having to install any software. Okay, so I'm gonna, if you want to get your screen like that, that's fine, and I'll go through the steps for getting into Repl.it right now. So I'm just going to go back to full screen. So here we are on the Repl.it homepage. I've got an account set up, so I'm just going to log in. Now, because I've got a Gmail account, I can log in directly, and I can click the G for the Gmail. So there's a lot of Joe blogs going around. So once I've logged into Repl, there's a lot going on here and a lot of options, but I'm just going to go and dive straight in by clicking on New Repl up in the top right corner. And the language we're going to do today is Python. Repl generates a name. You can change this name to anything you want, but I'm just going to click Create Repl for now. Okay, so this is what the screen is going to look like. There's a couple of small adjustments we're going to do. So for example, I am just going to get rid of this column by dragging over there. And now I've got two main parts. On the left is where I'm going to type my code, and on the right is where I'm going to see the results of that code when I run it. So hopefully everybody's kept up so far. So there are some basic ideas and concepts that all programming languages use, and what we're going to do is we're going to look at a few of those today just in Python. But if you go and learn a different programming language, you'll be learning the exact same stuff, but just it might be written different, or it might be using brackets instead of commas or something silly like that. So there's no big difference, and they apply to most languages. So you know, if it's a case where I'm going too fast or anything, you can send up a wee message there and hopefully I'll adjust. But I'm going to start off nice and slow and keep everybody on the same pace. And after this stream is finished, which will be in about an hour or until my neighbour starts using power tools, I'm going to make all the code available online in like little handy bite-sized chunks so you can review it to check your own code against it. What else? Okay, so I suppose the other thing to keep in mind is, because this is beginners, if some of you have had experience, you might be like, oh, there's a shorter way of doing this, or there's a better way of doing that, and you're completely correct. It's just that for beginners, we're going to go the long way around for the start. Okay, so the first thing we're going to look at, the first concept of programming, is output. And output basically means the computer is going to give us some information out. So it's the basic thing, and we're going to give that a go. Now, in case any of you are looking at this on a small screen, I'm going to use the magnifier on my computer. So if it gets a little bit weird, you'll excuse me. It's just so that I can zoom in on little parts of the screen and you can see what's going on. So the first thing we're going to do is an output, and the output command we're going to use is the word print, brackets, quotes, and any text that we want to include. So traditionally, your first program should always be the Hello World program, and that's the way it should look. You can see that you use the word print, lowercase, a bracket, little quotation marks, put in whatever text you want, close the quotation marks, and close the bracket. And when you're ready to try this out, you just go over here and you click on the Run button, and on the right hand side of your screen, you'll see that it should say Hello World. So congratulations, you've written your first program in Python. And if you want, you can have a play around there for a moment and just maybe do a couple of prints. And again, you just run it each time you make a change to your code, and up it'll come. So a couple of things to look out for. If something like, if you forget to put in a quotation mark there, you're going to get an error message. So the computer is smart, but it's not that smart. So when you run that code, you can see that you get a syntax error, which means that there's a problem with your actual code. And usually it's pretty good at giving you a guide as to where that problem is, line 2. So I can come over to line 2 and I can see, oh, there must be a problem in here. And it turns out anytime you're using printing a string, you put in a quote. So I've used that word string. So what does the word string means? Well, string means a bunch of text. So that's all a string is. A string is just a bunch of text that you want the computer to deal with. The computer doesn't have to understand what's in that string of text. It just treats it like a bunch of text that it doesn't understand. So another couple of things we can do with a print. By the way, you don't have to follow me exactly. You could like print your own words, obviously, or do 2 or 3 more lines while I'm talking, whatever you want. So another thing we can do is we can print more than one thing. So I could print the word hello, close my quotes, put in a comma, and put in something else. So it's a bit pointless, but I've just put in one thing, a comma, and another thing. So why would I want to print 2 things? Let's see if does it look any different? No, it looks exactly the same. So why would I do that? Well, you're going to see why in a couple of minutes. Okay, so it's a big surprise for you now. It's like December 25th. Okay, let's up the ante a little bit with the print. Another way we can do some printing is we can print multiple lines. So we can do 3 quotes, push down this, put in 3 quotes, and I can put a bunch of text in here. So and that's just a great way to be able to just print a bunch of lines. So let's see how that looks. There you go. So something I should point out here is that using blank lines is perfectly fine. I use blank lines all the time to space out my code, and the computer doesn't care. So it doesn't care about blank lines between slices of code. You can space it out as much as you want. It's a lot easier to read code when it's a wee bit spaced out, rather than like if it was all like that there. That's a wee bit tricky. So that is the basic printing, and that's the basic output. Now we're going to come back to output in a couple of minutes, but we're going to move on to the second concept of programming. And the second concept of programming that I think fits in is a thing called variables. So what is a variable? Well, I'm going to show you now exactly what a variable is. A variable in a computer is just a box. So you have to think of it like a box. So if you look at the example I've given, by the way, don't worry if you didn't finish the print stuff, because we're going to come back to that in a couple of minutes. You can leave it on your screen. So a variable is just a little box in your computer's memory. So you can see 3 variables that I've created there on my little amazing drawing. And you can see the first variable. So the my name is the name of the variable, so the name of the box. And whatever I put into that box is just inside it. So that box called my name has got the word John in it. You can see John's in quotes. And again, that means it's a string. It's just a bunch of text that the computer doesn't understand. You can see I've got another variable there called my age, and I've put a number into it. You can put a number into a variable, no problem. And the thing to remember about a number is you don't put quotes around it. So if you want to use a number, you just put it in without quotes. And you're not stuck to just using integers. You can use decimal, floats. These are called floats in computer. So like 22.865 is a float. And again, you can call the variable whatever you want. And variables are very useful. So if you've ever played a computer game, like the score is a variable. It's stored in a box. Your time left is in a variable. The number of lives you've got left is in a variable. So at some point, the computer programmer had to create a variable for the score. So that's what we're going to do. Now, how do you create a variable? Well, that's how I created those 3 variables. You just write the name of the variable equals, and what you want to put into the variable. So if I wanted to create that first variable, I just go my name is equal to, and then what I want to put in it. And remember, if it's a string, you put it in quotes. If it's a number, you don't put it in quotes. And if it's a float, you don't put it in quotes. And that's it. And then we can see what's in the contents of that variable at any time. And it's also useful to know that we can replace it as well with anything we want. So let's go back to the code. Okay, so we're back to our prints. Okay, so even if you didn't get this going right now, don't worry too much about it. So I'm just going to erase all 3 lines, and I'm going to create my first variable, and I'm going to call it my name. So there are certain rules for creating a variable. Number 1 rule is don't put a space into the variable name. So my name, and it's not going to be a big shock to you as to what I'm going to put into that. I'll put in John. Okay, so now if I run this code, nothing's going to happen, because all I've done is created the variable. I haven't printed it or shown it. So let's print it. Print. And instead of putting in quotes, what I'm going to do is I'm just going to put in the name of the variable. So if my name has got the word John in it, and if I print my name, it's going to print hopefully whatever's in my name. So let's go and run it, and let's see what happens. John. So that's great. We're happy with that. We can see that we've printed what's in the variable. Now what happens if I had put quotes on my name? Well, you can probably guess. It's going to think it's a string, and it's just going to print the word my name. So we don't want that to happen. We just want it to be John. Okay, so we're going to go back to something now that we thought about a second ago, and that was, do you remember we were able to print 2 things at once? So now we can make the computer look a little bit more intelligent than it seems. What I'm going to do is I'm going to do another print, and I'm going to put in my own string. I'm going to say hello, and then I'm going to put in my comma and put in something else. But instead of another string, what I'm going to put in is the name of my variable. And I'm also going to put in another string, so another comma, and this time it's a string, so I'm putting it in quotes. I should actually make that a small h. But so I've got hello, and then I'm putting in something different, which is the variable, and then another comma, and then something else different. How's the farm? Now, just to make it a little bit clearer, I'm just going to put in spaces here, but they're not really required, but it makes it a little bit easier to read. So I've got 3 things in this print, and I'm going to delete this print. Again, I'm going to go over and run it, and you're going to see, hello John, how's the farm? You can apply whatever accent you want to that. Okay, so just have a look at that and give it a go there for a second. Of course, you can add more to it if you want. There's nothing stopping you doing that. So I'm going to add a little bit to this. I'm going to create another variable called my age, and I'm going to set my age to the absolute truth, and you'll notice that I'm putting a number in this time, so I didn't bother putting it in quotes. Okay, so remember, a string goes into quotes, a number can just be written as a number. And if any of you remember your maths, an integer is specifically what we call that. An integer is a whole number that's plus or minus or 0. So minus 13, 152, 16, 0, minus 30, any number like that we call an integer. Okay, so let's play around with this now. We've got my name and my age. So let's change from how's the farm. Let's put in you are. I'm going to put in another comma. I'm going to put in my age. I'm going to put in another comma. I'm going to put in another quote, years old. Now it's getting a little bit messy, but if you just take your time and read it carefully, so it says the word hello, John, you are, 23, did I say 23? 23 years old. So let's see how it goes. Happy days, that looks great. We've done it. So we've done some input and we've done some output, and we've done some variables. So we're ticking along nicely now. So what we're going to do is we've done some output, and the opposite of output is going to be input. That means that we're going to give the computer some information, or the user, so the person that sees the program running, is going to give some information. But just before that, we're going to make sure that we're okay with data types. So data types can be a little bit tricky, and that just basically means what we were talking about. What's the difference between a string and an integer and a float and so on? So it's important that when we input data or use data, that we use the proper form. So because we're using an integer here and it's correct, there's no quotes around it, that means we can do some stuff to that. Look, we don't have to just leave it as it is, as 23. We can now do some maths, which is going to be interesting. So I'm going to slightly change this. Instead of saying you are, I will say you will be. And instead of my age, I'm going to put in my age plus 5. And we'll change that slightly. So now what I've done is a little bit of maths. I've got hello, John, you will be, and it takes my age, which is 23, plus 5, 28, hopefully, years old in 5 years' time. So let's see how it runs. Happy days. Again, that's doing some maths for us, which is great. And that's going to be important in the next bit. Now, one thing that is important is the ability to change, okay? So I'm just going to delete that for a moment. Hopefully these are all okay and keeping up. So let's look at my age. Let's pretend that it is actually a string. But because we've put it in quotes now, the computer doesn't understand it. So if I go to print my age plus 3, what's going to happen is I'm going to get an error message. And the reason is it's going to try and add 3 to my age, but my age is a string. So the computer thinks it's text, even though we can see that it's a number. So let's try that out and see the error message. Okay, and it can be a little bit hard to read, but essentially what it's saying is, you know, you've got string in here and you've got int in here mentioned. So right now we're not going to get bogged down with error messages. So what if I wanted to change it from my age is equal to 23 without taking away these quotes? So what I can do is something like this. And you might think, why is he bothering doing this? Well, you'll see why it's important shortly. So let's say my age is equal to int. Int stands for integer, and I can create these brackets. Now this is a special command, and what it does is anything I put in here, it's going to change it into an integer and put it back into the box my age. So if I put in my age, this is tricky looking. What's that doing? Well, it's taking my age, which is 23 in quotes, it's changing it to a number and putting it back into the box. So it's replacing it with my age. So my age is going from 23 in quotes to just 23. And now when I go to print my age plus 3, hopefully I won't get an error message. Happy days. So that's great. 26. Now we're going to see in the next section why that's important. Why is it important to be able to change something from a string into an integer? And I know that sounds a little bit technical, but it's going to make sense in the next bit. So the next stage is actually going to be input. So just to recap, we've done printing, we've done variables, and we've done data types. We haven't done too much on data types, but we're going to come back to that again in a little while. So right now we're on to input. Input is a little bit cooler. That means that the user gets to talk to the computer, give it information, so the information is going into the computer, and then the computer is going to use output to give us back out information. So if it's okay, I'm going to go ahead and delete what I have. Don't forget, all this code will be available to you in each step afterwards, so don't worry if you're losing the code that you've written already. Okay, so we're going to use a special command called input. And input basically means we're going to ask the user a question. So the question I'm going to ask is, what is your name? And that's how the command looks. It's got the keyword input, all lowercase, just like print, brackets, quotes with your question, and what will happen there is the computer will wait for the answer. So if I just run that, let's see what happens. What is your name? And you see that the computer hasn't finished the program. It's waiting for me to press the enter key on my keyboard. So I put in my name, press enter, and the program finishes. It doesn't do much. It's pretty boring. So the problem is, when the user answers that question, the computer has nowhere to put his answer. And we talked about this a couple of minutes ago. Where do we put answers, or where do we put anything we want to store? We put them in variables. So there's a very easy way to do this. If I want to put the answer to this question in a variable, I just put the variable name there. So my name is equal to whatever comes out of that question. And that simple line is so important. So you have to kind of think of how it works. It goes over here and asks the question first, takes its answer, and puts it into the variable my name. So let's try that out. When I've done, if I want to check if it's working, I would just print the variable my name. So let's try it. Run. What is your name? Let's go with something exotic like Frank. And it just says Frank back to me. You want to get more complicated? You know how to do it already. Hello, comma, my name. I don't know who says what's the news, but I know we'll run with that. Run it. Another exotic name. So you can see like the computer's almost conversing with you, nearly having a conversation with you, which is pretty cool. So we're going to take that up a step of complexity next. So now the next thing we're going to do is we're going to get it to ask a couple of questions, and then we're going to combine all those answers into the one bit of code. So let's start off with, we've got my name. I'm going to add my age. Don't worry, this data isn't going to be sent to me. God love you if it was. Okay, so it says my name and my age. Now I've got two inputs, which is great. So it's going to say, hello, my name. What's the news, right? So let's change that to you are my age years old. So nothing new there whatsoever, except instead of us having to put into the variable what it is, we're going to ask the user to put in whatever they want. And we've seen this line before, this print line. So let's run it. Joe, and Joe is 90, flat out in Python. So hello Joe, you are 90 years old. Brilliant. Now there's a slight problem. There's a slight problem with input, and I'll show you what the problem is. If I go to my age plus 2, we should be able to do that because it's my age is a number. So let's see what happens if I try that. My name is Joe and I'm 90. Oh, we get an error message. The reason we're getting that error message is because the input command works, but it assumes that everything is text. So it assumes that everything is a string. So that's a problem, because when we put in my age and we try to add 2 to it, the computer's thinking, well, I can't add 2 to text. So I'm going to give you an error message here. See, a lot of you think that the computer's smart, but the computer's not that smart. So what we need to do is, when the user puts in their age, we need to tell the computer, when you're putting that in the variable, change it to an integer first. So change it to a number. And you might remember this from the last time. going to look a little bit more complicated here because there's so much going on, but we use pardon me, int bracket, and we put a bracket at the end. So now what we've done is we've put this whole thing here inside int bracket, close the bracket. And sometimes the brackets can get confusing because you have to make sure that you've got 2 open brackets and 2 closed brackets and stuff like that. But for now it shouldn't be too bad. And what that'll do is it'll ask that question, get the answer, change it into an integer, and put the integer in my age. It's nearly working backwards, this line. The question's asked first, then it's converted to a number, and then that number's put into the box my age. And if I run that now, it should work. So Joe, of 90 years old. Hello Joe, you're 92 years old. Okay, so it's not accurate, but at least it's working. So what comes after input? Well, let's pause for a moment and let's do some maths. My favorite thing. So don't worry, when I say we're going to do maths, I'm just going to show you like the basic maths just to make sure that we're all okay, because you're going to need it in a little bit for a bit of a challenge that I'm going to give you. So I'm just going to, again, I'm going to delete everything that's here, and I'm just going to try out some maths to show you. So we can do addition, which you've already seen by just doing print and the little bit of addition in there. I'm going to delete one of those spaces. So print 2 plus 5. So let's run that. Whew. Okay, computer's correct, thank God. So what other ones can we do? Well, that's the basic addition. You can guess what subtraction is going to be. It's just a minus symbol. Multiplication is a good one. So if we want to multiply numbers, we use the star, which is usually above the 8 on your keyboard. So you have to press Shift and 8 on most keyboards. So 3, and again, you don't have to put in these little spaces I'm putting in. I'm just making them so that it's a little bit more readable for yourselves. So we can multiply. What about divide? Well, divide is /. It's down there on the right, lower right of your keyboard, or most keyboards. So that's 9 divided by 3 there. Here's an unusual one. You can guess what this is when you see the answer. And so let's just run that and make sure all that math is working. So we've got addition, subtraction, multiplication, division, and a mystery one. So you've got 7 to 24, 3.0, and 49. Now that 3.0 standard out. We're not going to get too worried about it right now, but it's just when you do division, it automatically changes the answer to what we call a float, which means it's a decimal number. So it's a number with a decimal point. So even though the answer's 3 even, it writes it as 3.0. So it's not a big deal. It's just something that might stand out to you. Now, we're not limited to just printing random sums on the screen. We can use variables. And this turns into something that's really handy. So what I'm going to do is I'm going to create a variable called A, and I'll set it to 5. And I'll create a variable called B, and I'll set that to 8. And what I could do is I could do print, and instead of A plus, or instead of 5 plus 8, I can write, well, print A plus B. So whatever A is, add it to B. So it's quite intuitive. Like, I mean, you should be able to understand that naturally. If A is 5 and B is 8, that should print the answer to 5 and 8. And you can see it there. Okay, well, what else can we do with variables? Well, we can mess around. Let's create a variable called C that is 5 multiplied by 8. And let's print C. Sorry, I didn't mean to say 5 multiplied by 8. I meant to say A multiplied by B. So, oops. You can see there that's straightforward enough. C is now going to be A multiplied by B. So A is 5, B is 8. Just something we're going to give you a heads up about. That equal to sign that we're all so used to is called an assignment operator. It's a very complex term for something so simple. An assignment operator. And technically, if I was explaining this to higher level students, what I would be saying is we are assigning 8 into the variable B. But in plain language, that means I'm putting 8 into the variable b. Now, we're going to want to remember that the equal to sign is the assignment variable, because that's going to come up in a couple of minutes when we're doing another topic. So we've done some maths. I better run that to make sure that I get the right answer. There you are, 40. So we've printed C, and C is 5 multiplied by 8, and 40 is the answer. So hopefully everybody's keeping up all right. We're going to move on to the next topic now. And once again, I'm just going to delete what we have here. So this next topic is an important one. It's called logic. So we're going to look at a part of coding that makes that, like, it's so fundamental and important to programming that this is what makes computers do what we want them to do. And this is how computers make decisions, and it's the basics of everything. Okay, so it's the very fundamental building block. It's called logic. And logic in Python, the most fundamental part of it is the if statement. So if does what it does in English, it checks to see if something is true. Okay, so we'll start off with something relatively simple. We'll say a is equal to 6. So I've created a variable called a and I've made it equal to 6. So here's my logic. I think it's easier if I type it out first and then explain it. So what's going to happen here is, let's read it from the top. So we're putting the number 6 into a, and then we're saying if a equal to 6, and then there's this symbol, which is a colon, sorry, and then you've got 2 more lines that we recognize, but you'll notice that these 2 lines are in from the margin, so that's called an indent. And the computer's smart enough to do it automatically for us, but sometimes you might have to do it manually. But it's just a couple of spaces in there, you'll notice, from the margin. Now what I'm going to do is I'm going to put another print here. I'll just say the end. Okay, so the first question some of you are probably thinking is, well, why are there 2 equal to signs here? So the reason that is these are called comparative operators. Okay, now I know that's a tricky word, but a comparison or a comparative operator basically means we're comparing 2 things. And the reason we can't use 1 equal to sign is because 1 equal to has already got a function which is here, and that's called the assignment operator. So if I said if a is equal to 6, that would put 6 into a automatically. So it's not comparing them, it's actually putting 6 into a. But we want to compare them by putting in 2 equal to signs. And what it's saying is, if this is true, then it's going to do the stuff that is indented. So it's going to do these 2 lines of code only if this is true. And when it's finished, it's going to come down here and carry on as normal. So you can see that the print, the end, is done as normal. It's in the normal position here on the margin. But these 2 are pushed in. Now, what we'll do is we'll see what happens, because it is true. We know that this is true. So let's see. So it says hello, and it says world, and then it says the end. So again, the program did this first, checked it, it was true, so it did this, then it did this, then it finished, and then it did this. Well, let's change it. Let's make a equals 7. So now let's check it. When it comes to here, this is going to be false. And what happens if it's false? Well, if it's false, it skips anything that's indented. So it skips any line, and we can put in as many lines as we want there, but it skips it, and it goes straight to here. So if we run this, what we should expect to see is just the end. Let's try that. I'll give you a chance to write out that code now. The end. There you go. So I'll leave it there for a second so you can have a look at it. All right, so that's basically logic. Okay, so I'm going to do a quick example that might be a little bit more complicated, and we're going to build it up. Okay, so stay with me now and let's see if we can get this going. So I'm going to delete this. I'm going to create a variable called answer, and I'm going to make it equal to 7. Now I'm going to ask the user for some input. I'm going to change that input into a number. I'm going to say guess a number so again, I know this is quite fast, but we create a variable called answer and we're going to set it to be 7, and we're going to ask the user a question, guess a number between 1 and 10. We're going to change that question, we're going to change the answer, sorry, into a number, which is what int is there for. Notice the 2 brackets over here, and we're going to put that answer into your guess. So now what we need to do is we need to check, is their guess equal to the answer, and if it isn't, what are we going to do? So let's start off with if answer is equal to your guess. So there's the 2 variables that we're checking. Don't forget your colon. And if it's true, what we're going to say is we're going to give them a message. If I can spell congratulations. Okay. Sorry about the box that keeps appearing there. It's a wee bit distracting. I think I can turn that off actually. Okay, so if answer is equal to your guess, we're going to print congratulations. Now, the second part of the if statement that we haven't seen yet is else. And else works with if, and it just takes a colon. You don't have to put any condition in the brackets. Okay, so what we call that a condition. This is something that has to be true, that if we're checking. And so if this doesn't run, this will run. And that's the good thing about an if statement, if else we call that sometimes, is that basically only one of them can run. So we check this, and if it's true, this runs, and if it's not, this runs. So only one of them will run. So again, let's run this code and see if it works. Guess a number between 1 and 10. We know the answer is 7, but I'll try 5. Sorry, you're wrong. Let's run it again. Let's try 10. Sorry, you're wrong. We know the answer is 7, so let's try the 7. Congratulations. And so we've made our first program that has actual very basic intelligence, and I mean very, very, very basic intelligence, but it's still the computer making a decision, which is pretty cool. What we're going to do now is we're going to just build this up another level of complexity. So the if else isn't limited to just if else. It has another tool called elif. And elif sounds complicated, but it's not. It's just a combination of else if. So what if we want to check more than one thing? And what we're going to do is we're going to use our guessing game to do that. So we're fine so far in that we're saying if the answer is equal to guess, print congratulations. Well, what if we want to give the user more information than just you're wrong? What if we want to say, you know, you're too low or you're too high on your guess? So we can do that. So what I'm going to do is I'm going to take this else if, I'm just going to delete this last line for now. And I'm going to use this new tool called elif. And elif is just like if, except it's the second thing that you would use. So if you've got more than 2 choices, you would use an elif. So this one is going to be slightly different. We're going to use greater than your guess. So I'm going to explain this now. So only one of these things can run, remember. So this is important. So the first thing is, if this one is not true, it checks this one first. If it's not true, it checks this one. And what's important to have is we're going to have an else. And the else will run no matter what. And I'll explain what's happening now. Okay, so we've now got 3 parts to our if. It checks each of these in order. So if the answer is equal to the guess, it's going to print congratulations. If the answer is greater than the guess, it's going to print you've guessed too high. And it's important to, I suppose, understand the greater than symbol. So the bigger side is the bigger answer. So if, and again, that's another condition that we're checking. So it's another comparison that we're making, a comparison operator. So if the answer is greater than your guess, it prints you guessed too high, else it'll print this. Now why does else not have a bracket like this? Well, because there is no other option. If this isn't true, so if it's not correct, and if it's not greater than the actual answer, oops, I've made a mistake there, haven't I? If the answer is greater than your guess, you've guessed too low, and that's too high. Shocking behavior for a maths teacher. Okay, so if the answer is greater than what the guess was, it's going to say you've guessed too low, and else. In other words, if these two aren't true, then there's only one other thing that could be happening, and that they've guessed too high. So that's why with an else, you don't have to put in a bracket like up here. We don't have to put in this and an else. We can get away with just that. And the thing to understand, I suppose, is that you can add as many elifs as you wish, as long as you only have one if and one else on either the start and the end. But you can put in as many elifs as we want. So let's try this out. So we know the answer is 7, so I'm going to guess lower. You've guessed too low. Let's try something a little higher. You've guessed too high. And we've got it. Congratulations. So that is one of the key points of any programming language. Logic. If, elif, and so on. Okay, so what about some other operators? Well, we won't go into it too much, but I'll put it in the notes afterwards. You've got other operators like that's greater than and equal to, that's less than and equal to, that's not equal to, which is going to be handy. So that's not equal to, and of course then you've got just your normal less than, greater than. So you've got all these different comparison operators that we can put into these spaces here, but we might see more of those later. Alright, we're ready for a challenge. So for the first couple of minutes, I'm going to do out the basic bones of the challenge, but then I'm going to get you guys, I'm going to give you some time, and I want to see, can you finish the challenge yourselves at home before I give you the solution. So what we're going to do is we're going to change tact, and we're going to create a calculator. So if there's any of my students on there, they'll be sick looking at this calculator, but we'll give it a go. So again, I'm just going to delete the code that I have, and again, I will be making this available to you afterwards, so don't worry if you didn't get it all typed out. And we're going to make a calculator. Now we're going to make a bit of a personal calculator. So I'm going to get the name of the user to start with. So we know what that's doing at this stage, hopefully. And what we're going to do is we're going to get the user to enter 2 numbers, and then we're going to give them an option list, and they can add the 2 numbers or minus them, multiply them, divide them, whatever you want. And so when they pick their option, the computer is going to say, you know, hello John, here's your answer, and give the answer to the sum. So it's an interactive calculator, and it's going to use kind of all the tools that we've learned up to now, but it's a great project to start with. So we've got their name. So let's get the 2 numbers from them as well. Okay, so I'll just call it first num. You can call it whatever you want. So first num is equal to, now just be careful, because remember, we want this to be an integer. We want it to be a number, whereas the name was not a number. What is your first number? I'm going to cheat slightly now, and I'm going to Control C for copy, Control V for paste. Copy and paste, the most essential programming tool in the world. Okay, slight change to the second line now that I've copied and pasted. I want it to be the second number. Now, it's a good idea when you're programming to always check every couple of lines that it's working. So I'm just going to scoot over here and make sure that it's working. John. Great, no error messages. So that's a good practice to get into, is checking your code. So the next thing we want to do is we want to present them with a little menu. Now, we had a look at this earlier, but I'm going to use a slightly different print here. So I'm going to print my menu to the screen. And I'm going to use the triple quotes. And basically, using this way, I can print loads of lines separately. You can, of course, just make this using loads of print lines. Feel free to change this to the short versions if you want. Oh, I'm taking a risk. Whew. Nearly missed that one. Okay, so that's just going to print a menu to the screen. Again, I'm just going to check it out. Let's try it. Only takes a second. I'll just put in rough answers. Great, menu looks fine. So the next thing, of course, is I need the user to enter 1, 2, 3, or 4, depending on what they want. So this is another question we're going to have to ask them. And again, it's going to be a number. Now again, I'm going to cheat slightly. I'm going to copy and paste this code. Copy, paste, and I'm just going to change it to a different variable. Let's call this one option. And it's still a number because they're going to put in 1, 2, 3, or 4. And I'll make it a little bit formal. Of course, you can change the question to whatever you wish. And we can test it now if we want. But I'm going to keep going for now, and I'll come back if there's any errors. So you can see now we're starting to get into a longer program. We're already at 12 lines. I know we have a couple of blank lines, but it's starting to look like a proper program here. Now, we've got this box that has the option in it. We've got a box with the second number in it. We've got a box with the first number in it. We've got a box with their name. So the next thing we want to do is we want an if statement, and we want to compare the option that they selected. So if the option that they selected is equal to 1, we are going to create a variable called answer, and answer is equal to the first num plus the second num. Okay, so we're going to compare their option that they selected to the numbers 1, 2, 3, and 4. So if it's 1, well, we're going to create this variable called answer, and we're going to make answer equal first number plus second number. Because remember, if they pick 1, that means they want to add the numbers, and the numbers they want to add is first number and second number. And when this if statement is over, we're going to print the answer. But for now, I'm actually going to leave it there for, I'll give you, let's say, 2 minutes to see if you can finish out that code. Now, it's going to be tough, but just have a go at it, and I'll freeze what's going on for now. Okay, so I think maybe I will look at the solution. And you know, with most things in coding, there's usually more than one way to do this. Okay, so you might have a slightly different version, but you know, it doesn't matter as long as it works. I think that's the key thing. But I'll go through the way that I would do it normally. So we've checked the first option. So remember, if we're using more than one check, we use an elif. Okay, so I'm going to check if option 2 is equal to 2. Sorry, if option is equal to 2. And of course, if it is, my answer is going to be the first num, and option 2 was subtraction, minus the second num. We can have another option for option 3, and again, we can use as many elifs as we want. And for 3, oops, small mistake there. And for 3, it's going to be a multiplication. Now, for the fourth option, you know, we can just say an else now, because if it's not 1, 2, or 3, it should be number 4. But instead, what I'll do is, and this comes down to the fact that you can do it many ways, I'll put in the fourth as an elif. Okay, so if they select option 4, it's division. And what I can do is I can put in my else now. Well, if it's not 1 and it's not 2 and it's not 3 and it's not 4, they must have put in something wrong. So they've put in the wrong option. So I've only given them 4, they might have put in the number 6 or something. So I'll say answer is equal to, there is no answer, you picked the wrong option. And again, don't forget your little quotation at the end. So that's our program. The last thing that remains is, after all the if statements are done, we want to go back to normal code, which is down here. And what do we want to do? We want to actually print the answer, but we're also going to print the name. So I'm going to print hello, and the name is your name. Your answer is, and we put in the variable answer. Now I know this is hard because you didn't have all the code on the screen in front of you and stuff, but let's try this out and let's see if it works. And if it does work, you should be proud of yourself, because it's like 30 lines of code. And if you were just beginning, that's pretty great going. So let's run it. I might just put on the zoom again. So what is your name? My name is John Boy. And what's your first number? Let's put in 4, and let's put in 9. And here's my option menu. So we'll try it once with multiplication. So 9 fours is 36, and it says nice and neatly, hello John Boy, your answer is 36. Let's run it again. Frank, 3, 5, and let's be awkward. Let's pick option number 9. Hello Frank, your answer is, there is no answer, you picked the wrong option. So there you go, you've created your first calculator. Now, I'm sure some of you have not done it exactly like I have. So what some people would do there is, some people would just, for simplicity, do a bunch of ifs. You know, and they mightn't even have an else. So some people might have had something like that. And if you have something like that, it's still going to work fine. You know, okay, so it won't do if I put in the number 9 as the option, but it'll still work fine. I won't go into the reasons behind not doing it this way. It's like, just very quickly, it just basically means that the computer has to check each of them instead of just checking one of them. And over time, with millions of lines of code, that adds up and can slow down things. But for us at this stage, we don't really mind about that. So congratulations, you've done input, you've done output, you've done variables, and you've done if-else statements. You've done a bit of maths, so you've got your logic covered, and you've done variable data types. So we've done a lot, and we've done a calculator project. So we still have time. I know it's 3 minutes to the end, but what I'll do is I will do a little bit on loops, and then I'll leave you, and I'll give you some links if you want to follow on with some more information. So again, this is all going to be available to you. I'm just going to take it away for now, so apologies if you haven't finished. So a loop is a great bit of code, and a loop allows you to rerun the same code multiple times, which is really handy. So if you think about a computer game and you're controlling a guy walking around in a world, and you know, if you're playing Minecraft and you want to put a block down, like, you can't have a bit of code for every single block that could possibly go down, so instead you reuse the same code, and that's what a loop does. So what we're going to look at, there's a couple of different loops. We'll just have a look at a while loop. So I'm going to create a number or a variable, and I'll just call it my number, and I'll set it to be equal to 0. And a while loop looks like this. While slight spell mistake. So while my number is less than 10. So you can see that it actually looks quite like the if statement, okay, but it's totally different. And the while loop works like this. It's still got some indented code. It will repeat whatever's indented until this bit up here is false. So in other words, while that bit that I've highlighted is true, it's going to keep looping around here and keep repeating this code until this is false. So if my number is 0, is this true or false? My number is less than 10. Well, that's true. So what the code will do is it'll check this, and that's called a condition. Another fancy word, it's a condition. And it'll check the condition, it sees that it's true, and it'll run this line and then run this line and come back up and check the condition. Has the condition changed? No, the condition is still true. So it's going to go and run these two again and check again and check again and check again. And the computer is really, really, really fast at checking. So let's run it and see what happens. It just goes on and on and on and on, and it's still going, even though it looks like it's frozen. The computer is still going. I have to stop it. Okay, so by the way, if that freezes your computer, if you just press refresh, it'll get it going again. But I was lucky it didn't. So in other words, because this is always true, it'll just print it forever. So how do we make it not always true? Right, well, let's just change some bits here. Instead of let's printing hello, let's print my number. Okay, so we haven't changed anything. It's just going to print my number instead of hello world. So let's run it. My number is 0. So it just prints all these zeros and keeps going to infinity. Okay, so I just click stop there to stop it doing that. Now, what I'm going to do is I'm going to add 1 to my number every time round. So every time it runs this, it's going to take my number and it's going to make it equal to whatever's already in there plus 1. I know that's a wee bit strange, but if my number is 0, it's going to take 0, add 1 to it, which gives you 1. That's years of experience as a math teacher. And it's going to take that answer 1 and put it back into my number. So now when it comes up here, my number is going to be 1. And 1 is still less than 10. So it's going to do this again. It's going to print my number, which is 1. And then it's going to come down here and it's going to take my number, which is 1, add 1 to it and get 2, and put the answer back into this my number. So now my number is 2, and so on. So can you guess what this is going to do? Let's try it out. So we've run it again, and that's what we get. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And you can see how quick it was, the computer running around through those. It's very, very quick. So, you know, I can change this to, you know, keep doing it while it's less than 100. And if I run it, you know, it's in the blink of an eye. The computer can just run through those numbers so fast. Just going to clear the screen. Okay, so that is a while loop, and a while loop is a great use. So I could do something like this. I could say, let's change it from my number is equal to 0. Let's say, let's ask the user. So my number is equal to, let's change it to a number, and let's ask the user to enter the number. And what it's going to do is it's going to count it. So I'm going to create another variable called count. I'm going to make count equal to 0. So you can imagine if the user puts in, let's say, 50. And so I've got this variable called my number, and it's 50, and I've got count as 0. So what I'll say is, I'll say, while the count, which is 0, is less than my number, which is whatever the user puts in, let's say it's 50, let's print count. And let's add 1 to count every time. Now, I know I'm going a little bit quick here, but let's just think about this for a minute. Enter a number, so let's say it's 50, and you've got count as 0. So while count, which is 0, is less than my number, which is 50, so while 0 is less than 50, it's going to do this. So it's going to print count, which is 0, add 1 to count, come back up. 1 is less than 50, yeah. Print 1, now count becomes 2, and so on. And what you've created is a very simple way for the user to print out as many numbers as he wants, or she. So let's say I enter number 5. 0, 1, 2, 3, and 4. So it prints out 5 numbers for me. Of course, if you'd rather the numbers 1 to 5, let's see if this works. Or is there a problem with this? Okay, let's start count at 1. So let's say 5 again. This time it only printed 4 numbers. Why do you think that is? Well, because count was 1 higher. So what we should do is we should put my number 1 higher. These are things that you can play around with in your own time, and these are the kind of challenges that you need to test yourself with. So let's run that. Enter number 5, gives me the numbers 1 to 5. Enter the number 10, gives me the numbers 1 to 10, and so on. Now, you can have a play around with this and do things like, let's go up in 2s. Instead of adding 1 to count each time, let's add 2. Let's go to 100. 1, 3, 5, 7, 9, and so you're just going up in 2s from the number 1. So you could change the starting point, you could change how much it's going up by, and next thing you're generating the times tables and so on. So I think we've gone over the hour, so I might leave it there. We didn't get a chance to go any further, but it'll be interesting to see if you can go ahead and apply some of these things that you've learned. Now, I am going to share on social media, so if you follow the Twitter account, I will put out the link to all these files. So each file is done individually and it's got the comments in it. And so a comment, just before I let you go, is basically a hashtag at the start of the line, and you can type whatever you want in there and the computer basically ignores it. So it's a really good way to kind of track what you're doing and to record what each bit does, and the computer just ignores it. So it's really important as a professional programmer that you use comments. So that's really it. I hope you enjoyed it. I am going to log off now and I will share that with you. And again, if you have any questions, you can send me an email or send me a message on Twitter. So thanks for tuning in and good luck.